So roof and skylight is covered, and next is the infiltration. So in infiltration, you can see you can take the CFM as per ISHRAE 5 CFM, 5 to 10. Okay, I am taking 10 for heating also. Next important part uh, is infiltration occurs. Two options we have: only when fan off. Next is the all hours. If you are opting for this option, okay, it will not the calculate the infiltration load for this room. Okay, if you select only when fan off, okay, and if you select all hours, then it will calculate the load for from the infiltration into this room. Okay, this is the only difference that we have in this only when fan off and all hours. Okay, rest you can give the value that this by the thumb rule we have 5 to 10 CFM for heating and cooling. Next is the floor. Okay, in floor you can see four options we have. Like the floor, like the room which you are designing is above the conditioned space or above the unconditioned space. Means like if you are calculating the load which is of the room which is on the first floor, and below on the ground floor the room is conditioned, means नीचे वाले फ्लोर पे एयर कंडीशनिंग हो रही है, ठीक है, like on the below floor we have the air conditioned space, then we'll opt for this one. But if the floor below of the design room is unconditioned, then we'll opt for this one. But if the floor on the ground level which we are designing is on the ground level, that will select slab floor on grade. But if the floor is below the ground level, means the basement, then we'll opt for this one. Okay, like in our case, we are doing for the energy for the cooling load calculation of the floor which is on the grid, means the ground level. Okay, so for ground level you can put the values, like this is asking for the floor area. So the floor area we have 150. Okay, u value, okay, u value you can put it as like what we have calculated. Just go to this roof and floor u value is 0.47. Now coming to the space, put 0.47, 0.47. Now it is asking for the exposed parameter. Okay, so you can see in your project, the exposed parameter is this one only, means the 10 feet this length and 15 feet this one. This is not exposure, na? Are you getting?
Yes, sir. 25 feet.
Exposed parameter is 15, 50, 10, means 25 feet. Okay. Now go to the
Where?
yes. Now it is asking for edge insulation R value. Okay, insulation, edge insulation is what? Okay, like can you see this word file?
Yes.
In this word file you can see this is the foundation wall and this is the slab on which we are going to design the room. Okay, above this one, and below we have the soil, na? So in this foundation wall we do some insulation, okay, just to resist the heat. So it is asking for this insulation R value. Okay, this insulation R value will be given by the architecture. Okay, now we are taking it as 0.5. Okay, 0.5 edge insulation. If you are not having, just put it as 0. Okay, if you are not providing insulation, the edge, you can put it as 0. Okay, no problem. Next is the partition. Okay, in partition you can see one is the ceiling partition and next the wall partition. When will you select as the wall partition? Okay, first I'm selecting the wall partition. So in wall partition, first wall partition means this one. This is the partition wall, no? Because it is not exposing this 15 feet and this one. So this will be this will come under the partition wall. So going to this app software, now you can select the area first. So what will be the area of the partition? Anyone? on the online? What will
Yes,
be
sir.
the area of the partition wall? Like it is asking.
250 square feet.
10 by
15 plus 10 perimeter into height 10 feet. 250 square feet, sir.
Exactly. But
window size we need to
Door is a deduction.
yeah. So area is 250. Take 250. Not just make much difference. We consider the two. Next, the U value. Okay, U value we have created now. U value you can see in the walls. Partition wall U value is 0.5.
0.5.
0.5. Go to the space, office, and partition 0.45. No? Now it is asking unconditioned space maximum temperature and just listen it carefully. Ambient at space maximum temperature. To one set this one, and next is unconditioned space minimum temperature and ambient space minimum temperature. So first, like I'm putting is 0 first. Okay. So first I'll discuss this ambient space minimum, ambient space maximum. Okay. So what is the ambient space maximum? Ambient space maximum will be like we are designing for New Delhi. No? So New Delhi, you can see the value which is giving here, dry bulb temperature. Is the dry bulb in Uttar Pradesh, New Delhi is 110. This is the ambient maximum value. Okay, ambient maximum value. So it is taken as 110. So I'm putting it as 110 ambient space maximum. Okay. Now coming to this unconditioned space maximum temperature means it is asking for this unconditioned space maximum. This is the unconditioned space now. That is why it is a partition wall. If it is a conditioned space, then in that case it will not be a partition wall. So this is asking for this space temperature. So outside if we have 110, so what will be having inside this in the unconditioned space? Plus minus 5. Okay, so if it outside is 110, then in this unconditioned space will take 105, 5 less than outside. Okay, understood now? So and unconditioned space maximum temperature will be 105. Okay. Next we have ambient at space minimum temperature. Okay, ambient space minimum temperature. So you have the value for maximum temperature, and we have one formula. Here you can see this Word file is visible now.
Yes.
Okay, daily range is equal to ambient space maximum temperature minus ambient minimum temperature. So first we know the daily range. Okay, so what is the daily range of Delhi? Go to this PDF file, and here is the column for daily range. Okay, daily range for Delhi is 25 na. Coming to the Word file, 25 is equal to maximum temperature what we have 110
110.
minus minimum we want to know na? Minimum we want to know. So x will be x is equal to 110 minus 25. Okay, so what will be the value? 110 minus 25, 75,
90.
85 no? Okay,
Okay.
understood this calculation? Any doubt in this? No. Okay. Okay. So we have 85. Going to the head. Ambient space minimum temperature 85. And for unconditioned space minimum will take 5 degree less. So 85 to 80. Okay. This is for wall partition. Next is for ceiling partition. Ceiling partition similarly we have, but in our case we don't have any ceiling. We directly have a roof. Na? Same values you can put it for the ceiling also. Like if your ceiling, like the floor area will be 150 square feet, value for ceiling and air condition, these parameter will be same like in this one, because we have the same now. So like in this case I'm using 0, it will not calculate for the ceiling. Okay, but parameters are same, you can add it if you are having the ceiling. Okay, now click OK. Okay, next we'll go to the system. In system we just select only with the name, like in this asking if you are using uh, any system like for package. So I'm using as package unit. Okay, equipment type package rooftop. Okay, we're using for single zone. Next, system component will ask for ventilation, means if you are providing for the constant. Okay, for schedule we also we have, but generally what we use the constant. Okay, airflow control, like this will be given by the manufacturer of the machine. Okay, airflow control what they are using for the package unit or the rooftop unit. And the ventilation sizing, ASHRAE, from the starting point we are following the ventilation standard as per the ASHRAE. Okay, unoccupied damper position, like the space in which it is unoccupied, the damper will be closed, that is okay. Damper leak rate 5%. Okay, normally we use this, is taken by default, you can change it. Outdoor air CO2 level, outdoor air CO2 level will be confirmed after the CFD analysis, computational fluid dynamics, but as a thumb rule 400 CFM you can take. Okay, 400 CFM. That system,
Hello.
yes, yes.
Yeah, that's unoccupied is there, no, sir? Unoccupied damper position. Can you say what is that?
Unoccupied, if the space is occupied, means you are not air conditioning na?
Okay.
So in that case the damper, if the damper is closed, then air will be flow in that unoccupied space na? That will be completely lost. So if the space is occupied, in that case the damper for the duct will be closed, so no air will be supplied to that room because it is unoccupied. Okay, in the duct system just add the heat gain, like I'm adding 10%, leakage 5%. Okay, going to the zone component, you can see spaces, add this space in the zone. Okay, thermostat, we have to create the schedule for thermostat. Okay, create schedule like this one. Click OK. Wait, available. Follow error message. Just add the zone. Share data. Occupied zone is not. Just wait, let me check. Let me check the schedule we have created for this one. Like create this one first. For panther thermostat, and here add thermostat. Okay. Click OK. Panther thermostat, now going to the system. From component. Add general package unit. CAP 5%. Okay. We haven't created the schedule na, in this schedule. That is why it was asking. Okay. Supply, no need to change in this one. Sizing data, cooling sensitive safety factors, 5% in this one, 5% in this one. Okay, package unit. Yes, system is ready. Now right click this one and print view design result. Click preview. Okay. This is the sizing sheet. You can see the total coil load 2.6 tons and all the details that you have put. We'll see you can this one. Like zone 1 design airflow, maximum airflow, zone 1, or design cooling, design heating, partition, infiltration, miscellaneous. We haven't put any miscellaneous infiltration. So this is the report that we have generated for heating and cooling load calculation. Okay, understood?
For heating, how much ton? For cooling, how much ton? Where we have to see? How to read that report?
Can see na? Heating is maximum coil load. MBH you can convert into ton. Na? Actually, heating is generally being calculated in MBH. MBH is unit of like the energy, like we have the ton. Central coil sizing data.
Okay.
Okay. So this you can convert into a printer also, like in the PDF, and save it to the desktop report. Let's save this one. And so we'll share this PDF. Okay, just go through this all. If you find any doubt, you can ask me on the WhatsApp. Okay, this is all for happy. Okay.
Okay. This one thing is regarding the software. I have not received the link. I have downloaded from the carrier side. Does it?
Actually, I've shared the link on the group. This link is not working.
No, I have not seen the link in the group. I think I have downloaded from the carrier side. That is the same software or something else is there?
No. I think you have to pay for that if you are downloading from the carrier side.
Okay, but I have downloaded from there only. Can you share the link in the group 1 second because I couldn't find it. I think maybe you shared on the mail.
Okay. I'll share again. I'll share you the link on the WhatsApp.
Yeah. Yes.
Hello, sir.
Yes, sir.
While you are doing in that HAP software, no, I came across that one thing: pre-cooling, preheating. That and all, what, sir? In systems,
that is the
economizer.
That is the part of equipment sizing. Equipment sizing, but we are concerned with the cooling and heating load calculation. In HAP. That is a part of
inside the AHU. Inside the AHU, there will be coils, no? So that also we can give here. Economy.
But that in the case of equipment selection, na? After you calculate the heat load, then after you do the equipment sizing. Okay.
That you will show how to do that one.
Actually, that will be a separate portion for the plants. Like plants also not covered, na? Because it is a part of the equipment selection. Plants and energy analysis and the cost estimation. That is a complete portion, separate portion.
That is not included in HAP.
No. That is included in HAP software. But as per your syllabus, I told to cover the cooling and heating load calculation. Okay, any doubt if you find, you can just ask me after this class is being over. You can ask me, okay? Define a
Okay.
Okay, just I'm adding the
Okay, sir.
meeting.
Okay.
Have a nice day.
Okay. Thank you.
Thank you.